What?
So today we're going to prove the Pythagorean theorem. So a little history about the Pythagorean theorem. It was actually invented by a mathematician named Pythagorean from around 400 to 500 BC. And the Pythagorean theorem actually helps us solve a triangle that only has two given sides. So what is the Pythagorean theorem? To solve this triangle with only two given sides, they actually do c squared equals a squared plus b squared, or a squared plus b squared equals c squared if you want. Okay, so right now I'll give an example of how to use the Pythagorean theorem. So first, we draw a triangle. Let's make this a bit longer. Okay, so we have given sides 3 and 4, and then we have x for the not given side. So how do you get this? Well, knowing that we're using the Pythagorean theorem, we also know that this is A, this side is B because it's the longer side, and this side, the hypotenuse, is C. And using the Pythagorean theorem's formula, we know that this A, 3, plus 4, which is B, equals x, which is C. So also using the Pythagorean theorem's formula, we know that we have to square all of this. So we have square, square, and square. So all we need to do here is simplify this. So we have 9 plus 16 equals x squared. And to get this, we need to square root both sides. It's 9 plus 16. Square root of 9 plus 16 equals x square root of x squared. And then you simplify this. 25 squared equals x, which is actually x equals 5. So we know that this missing hypotenuse is actually 5. So it may be so simple just to use this Pythagorean theorem for stuff that you can't get and story problems. But then, do you understand the formula of the Pythagorean theorem? How can we actually know that this is actually correct? How do we know that it's actually legit? So the key to solving the Pythagorean theorem, or how to prove it, is actually using squares. Squares are actually used by geometry mathematicians to solve a lot of theorems. So besides using this square, we also need 4 triangles. So using these 4 triangles, we can start with one triangle. So we know that it's A, B, and C. Then we can make another triangle. And this is B. This is the longer side. This is A. And this is another C. And we can make another triangle. So this is B. This is A. This is C. Then we can make one more triangle. And this is B, A. And so now we have this big square. So we actually also know that this big square has one small square inside. So the key to proving the Pythagorean theorem actually lies in this square. So we know that there's this one big square and one small square. So the key actually is to get the area of the big square and prove that it's correct. Well, we know that the area of the big square is actually the area of this small square plus the area of these 4 congruent triangles. Now, how do we get the total area? Well, we know that one side is A plus B because this is A and this is B. So we now know that A plus B squared is the area of the big square. So why did I square it and not use the fourth power? It's because we all know that a square is actually one side times one side equals the area. Now to get the area of the smaller square, we know that all the sides are C, so we can just say that it's C times C, or C squared. Then, for the four congruent triangles, we need to get the area first of one triangle. So, how again do you get the area of a triangle? It's actually one side times one side over 2, divided by 2. So, we have B times A over 2. And we also know that there are 4 triangles, so we have to multiply this by 4. Now, to prove that we have a legit solution, we actually need to simplify it. So, simplifying solution, like an old lesson, this is actually a binomial, and it's a perfect truth. So we can say this is A squared plus 2AB plus B squared. And then we have the other side, I'll just put it at the bottom, C squared, so we'll just leave C squared there. So we have B times A over 2 times 4. We can cancel out 2 and 4, and this will become 2. So we have plus 2AB. So the final solution we have is A squared plus 2AB plus B squared equals C squared plus 2AB. Now, I don't think this really looks like A squared plus B squared equals C squared yet. So what do we have to do? We have 2 ABs on either side, and both of them are positive. So we can use the ABE and minus 2AB from both sides. And you can cancel it out. And there you have it. A squared plus B squared equals C squared. So now that we know that the Pythagorean theorem will actually work, now we can use it in real life situations, such as this one, concerning my friend Leo, who wants to train for his football competition by running across the field. So here is our starting problem. Leo is playing football on a football field which happens to be the Xavier School field. He practices dribbling by running with the ball across the sandy field. If the field was 14 meters wide and 15 meters diagonally across, how many meters will he have to run to get to the other side? And if he runs back and forth, how much meters did he run? So right now we have the diagram of the problem which I drew, and this is Leo here. So actually, since we are given the 15 meters diagonally across, we can actually use the Pythagorean theorem to solve this. Because right now we have the hypotenuse, which is C, this, the width A, and the length Leo has to cross, B. So using the Pythagorean theorem, we can now say that 50 squared is also equal to A squared, which is 14 squared, plus B squared. Since we do not know the length Leo has to run, this will be B. So solving this, all we have to do is square these two, and we have 2500 equals 196 plus B squared. And then, to seclude B squared, we need to subtract 196 from both sides. So 196 minus 196, and this is, by the way, called APE, or something, SPE if you want to, subtraction. So we're gonna have 2304 equals B squared. 2,304 may be a little hard to, square root because it's a really big number. But through hard work and patience, you will be able to get. First, I will simplify it. 2,204 to take out the square. It's actually 48. So now we know that the length Leo has to run to get to the other side is 48 meters. So we have answered letter A. Now, how are we gonna answer letter B? So if he ran back and forth, so he ran to the other side, and to practice some more, Leo ran back to where he started. How much m did he then have to run? Actually, this is more or less common sense, but all you need to do is multiply 48 or add 48 with itself because he ran it twice. So you're gonna have 96. So if you ran back and forth, Leo ran 96 meters. So in many real life situations such as ladders, how far a ladder would be from a wall so that it can reach the top, or flagpole problems like how far do you have to pull the flagpole to, so how far would a person be to pull a flagpole? The Pythagorean theorem can come in handy in many ways. This is just one of them, and you can explore the world of the Pythagorean theorem even more. Thank you for watching.
First shot, come strut walking. A little bit of humble, a little bit of cautious. Somewhere between like Rocky and Cosby's for the game. Nope, y'all can't copy yet. Glad moonwalking, and this here is our party. My posse's been on broad.